Yes, students, today I have defined you the Hermit interpolation formula. Yes. According to this formula, if f dash is continuous on AB and x0, x1 up to xn belongs to the interval AB are distinct, then the unique polynomial of least degree with f and f dash at x0, x1 up to xn is a polynomial of degree at most 2n plus 1 given by this one. This is the formula. Okay. Pn x is equal to sigma I varying from 0 to n 1 minus 2 times x minus xi li square x and fi xi, where L is the Lagrange interpolation. You have studied this term earlier, okay? And the plus sigma I varying from 0 to n x minus xi li square L f dash xi. Okay, now we prove this formula. Yes, the Hermit interpolation, actually we want to define you the Hermit interpolation. Actually, in the Hermit interpolation is not only the function f of x but also its derivative at a given set of points. Actually, if we define a set of points from minus infinity to infinity, that is, the interval is defined as like that is, if you define there is so many points in this interval, from here, there is interval in AB. So the derivative at a set of points pi xi is equal to f of xi and p dash xi is equal to f dash xi, I varying from 0, 1, 2 up to n, and the px which become sigma I varying from 0 to n aix, and the formula is this one. We have to prove this one. Aix xi, this one, plus sigma I varying from 0 to n bix and f dash. Now we want to determine the where ai and bi are polynomials having degree less than or equal to 2n plus 1 and satisfying the conditions given below. Okay, actually in this formula you have obtained this one. Okay, this one you want to obtain, and here is also you obtain this one. Yes, so you have suppose here this is ai and bi using the conditions, and here the conditions are aixj is equal to chronicle delta, or you say that this is equal to 0 if I is not equal to j. Yes, and this is equal to 1 if I is equal to j. Yes, and similarly the derivative of this is a I dash x j, this is equal to 0 for 0 and for every I and j, yes, for every ij, and also second one for b. Yes, the condition is defined as b, yes, I x j, this is equal to 0, yes, and for b dash d dash x j, this is equal to 0 for I is not equal to j and is equal to 1 for I is equal to j. Yes, clear? I is equal to j. Yes, these are the conditions. Okay, now using these conditions we obtain ai and bi. Yes, these are the inequality conditions. So using this, and now we found out this one. Yes, on next page I have defined it. Here we are using the Lagrange interpolation, because here this one is in this formula, this is the Lagrange interpolation. Yes, so we have using here the Lagrange interpolation formula. Okay, using the Lagrange theorem we have Yes, Lix. Yes, you know this one is x minus x0, x minus x1. Yes, up to x minus xi minus 1, x minus xi plus 1, up to x minus xn, and denominator is, yes, xi minus x0, xi minus x1, yes, up to xi minus xi minus 1, xi minus xi plus 1, yes, up to xi minus xn. You know this is the Lagrange interpolation formula. By using this formula, let me write in the form like that. Lix is equal to, yes, because for the derivative term, so we want to define you, actually the value of Lixi is equal to 1. And similarly Lixj, this is equal to 0. Yes, you can find, you can easily evaluate this thing. If in short form, if you write Lix, let us in the terms of omega x, and the term at a point xi, that is derivative of dash xi. This is a short form of the Lagrange interpolation. Yes, x minus xi. Yes, this one. If you prove this one, then at a point xj, yes, then because this is the polynomial of x minus x0, this one, so the point xj, all the points are lie in this interpolation, this interval. So Lixj, this is equal to 0. But if you substitute here Lixi, then xi is here, so this is the always from for because it is for xj, this is also 0, because these are the zeros or lies in this omega x. Though for xj's also 0, xi is also 0. So this is the form of, if you substitute here xi, then this is 0 and this is, that is the form of the 0 by 0. So you apply the Dipper's loop, and according to this, here you this can say that w dash, yes, w dash xi, and denominator you also become w dash xi is written earlier, and this become 1. So this is equal to 1. So Lixi, this at this point the value is 1. Okay, we can prove it this one like that. Okay, now you know this one. Okay, now we start to solve ai, yes, ai x. Let us suppose that this is equal to gamma I x li square x, and where we take a polynomial is like that, this is equal to aix plus bi li square x. Look, suppose that this one, yes, dot aix, yes, this 2n minus 2, so degree up to n minus 1, so 2n minus 2, and here is 1, the 2n minus 1. Yes, now therefore if you apply the conditions, and the conditions are earlier here, conditions are here, ai xj is equal to 0 and ai at a point xi, this is equal to 1. You prove that this is true. So if you operate here xj, yes, ai xj, then you see, because in Lagrange interpolation the zeros for xi's are here and xj's are here, so this become always 0 for x. You can say from here also, yes, this you can say from here, not from here. Okay, you can clear it. xj, then this is equal to 0. Okay, so this term is 0. 0 multiplied by this one, 0. Now the next one, if you operate at a point a I x I, then this become a I x I plus b I, and here is L I square x I, and this is equal to, yes, here you see that this is equal to 1, so this can be written as, and also from the condition when the point is x, this is I, then the value is, when xj is I, then this is 1, yes, so you can substitute here 1, yes, that is 1 in place of this is 1 is equal to ai xi plus bi, and this term, this value of this is 1. Yes, clear? Let us suppose this is equation number 1, and now we take the derivative of, because the next condition is the derivative of a dash, this one is equal to 0. So from here, if you see from here, and that is, you have to take the derivative of this is, that is a dash ai dash x here, derivative, yes, then this is equal to ai, yes, and li square x plus aix plus bi, and derivative of this is 2 times lix and also li dash x. Okay, now you see that this one from the equation number 1, this is equal to, the value of this is equal to 1, and according to this is equal to, here this value given as for I is or j, everything is for j is for I or j, follow, this is equal to 0. Yes, so this term you can write here is this to be 0. Okay, now here ai, and at a point xi, you see that this is equal to 1, so ai, yes, and here at a point xj, each and there, from there, this is equal to all terms of 0, but for 1 I, this is 1, yes, and this is again here is 1, so you can write here 2 times lixi is also, again you can say that lixi and li dash xi, this is again 1, so this is ai, this is equal to minus of 2 times li dash xi. Yes, clear? Okay, and similarly from this, from equation number 1, you can evaluate bi, then bi become, according to this, from using the equation number 1, this is equal to 1 minus, yes, 1, and then minus of this is, then this is bi is equal to 1, yes, plus 2 xi li dash xi, yes, this one, yes, 1 I not here, substituting here, then this a1 ai become 1 minus, yes, bi is this one, yes, okay. Okay, now the next term is equal to, you have to substitute this one. Similarly, yes, you have clear, okay, so aix, substituting these values, ai and bi is here, yes, so ai is and bi is here, substituting this one, ai is this one and bi is this one, substituting here, so you get the aix, and you get aix, you get 1 minus of this is, that is, you get aix, you get ai, that is this one, bi, that is this one, that is, you get 1 minus 2 times x minus xi, yes, this multiplied by li dash xi, this one, this one you get. Yes, clear? Okay. Now, from the second, similarly you can also obtain BIX. Yes, and BIX, and for BIX you supposed to be the BIX delta IX and LI square X, and let us, this is CIX plus DI, and here is again LI square X. So BIX is, let us, this one. Okay, now you, on the same way you can also calculate the value. If you substitute, here is BI, here you see condition is BIXJ is equal to 0 and BIXI is again is equal to 0. So here you see BI, because of this BIXI, then this is equal to, here is 0 again, but here is at a point x0, this is again 0, but at a point xi, then CI XI plus DI. Yes, you can see equation number 2. Okay, and now differentiating this one, BI dash X, this is equal to, differentiating again here, CI LI square X, yes, plus CIX plus DI, okay, 2 times LIX and LI dash X. Now here you see the condition for all. If I is not equal to j, then this is 0. If I is equal to j, then this is equal to 1. Yes. So from here it is clear, when you substitute xj, j from this is 0 and according to this is 0. So you substitute, if I, then this become value is 1. BI dash xi, it is given the condition is 1. And here is, this is again become 1. Li square xi, yes, according to this is equal to 1. Yes, plus here is also CI x di, this is equal to, from equation number 2, this is given 0. So you get CI is, everything is 0, or you get the value is CI is equal to 1. So from equation number 2, CI is equal to 1, then DI is yes, minus xi. Yes, okay, clear? So in that way you calculate all the values. Now substituting this one, BIX, so BIX, this become x minus, yes, x minus xi Li square x. Yes, clear? Okay. Now substituting these values, okay, substituting these values, AI from BI from here, okay, and AI from AIX from here. Okay, substituting these and these values, you get Px, yes, you get Px is equal to sigma I varying from 0 to n, 1 minus 2 times x minus xi, yes, and 1 minus xi, Li, yes, dash xi, Li dash, close this bracket. Now Li square x and also fi xi. Yes, first term, and similarly the second term is sigma I varying from 0 to n, yes, x minus xi Li square x f dash xi. This one. Okay. Now this is the form that you have to find out the Hermit interpolation. Okay, yes, clear? Now next time, this is the Hermit interpolation formula. You find out, you make it, this problem is AIX, this is the interpolation, the thickness, AI and BI are the polynomial, yes, of at least degrees 2n plus 1. So you substituting here is AIX, this is like that. By using these conditions, you evaluate using the Lagrange interpolation formula. Here we have, you obtain LIXI is equal to 1 and LIXJ is equal to 0. Using this, you operating the conditions, now we get this one. Okay, yes, thank you students.